the Big Bang Theory, the most widely accepted explanation for the origin of the universe. It describes our universe's birth from an incredibly hot, dense point known as a singularity. It's a point of infinite density and temperature, a place where all the laws of physics as we understand them cease to function. A single tiny point birthing all of space and time, every galaxy, every star, every planet, and every speck of dust. It's a concept so grand it boggles the mind, but here's where things get even more intriguing. If the Big Bang marks the birth of our universe, what existed before? What could have possibly happened before this cataclysmic event? One intriguing hypothesis proposed by James Hartle and Stephen Hawking is the no-boundary proposal. This theory takes us on an interesting journey where the conventional understanding of time and space takes a back seat. The no-boundary proposal suggests that the universe didn't have a start, at least not in the way we perceive it. Instead, it asserts that the universe was always there, in a state where time was bent, so to speak. Now, what does it mean by bent time? Well, imagine a sphere where the concept of a start or end doesn't exist. Just like you can't pinpoint the start of the surface on a sphere, the no-boundary proposal suggests that the universe didn't have a definitive start either. Time, instead of being a straight line, was curved, and it gradually straightened out to the linear concept of time we understand today. This theory is a bit like saying that before the Big Bang, time was more of a spatial dimension, much like length, breadth, or height. Just like we can't go north of the North Pole in a similar manner, before the Big Bang doesn't really make sense in this model. In essence, the no-boundary proposal isn't merely a theory about the universe's inception, but it's a radical rethinking of what time itself means. It suggests that time didn't always flow in a linear fashion as we know it. Instead, it may have been in a bent or curved state. This radical idea, while still a hypothesis, is our relentless quest to decipher the mysteries of the universe's origin. In this theory, asking what happened before the Big Bang is similar to asking what is north of the North Pole. Another fascinating theory is the multiverse theory. This intriguing prospect suggests that our universe, the one we know and live in, might not be the only game in town. Imagine, if you will, countless universes, each existing independently yet concurrently. This theory, in essence, posits that our universe is just one member of a vast ensemble, a sprawling collection, if you will, of universes collectively known as the multiverse. Now, this isn't a simple repetition of identical universes. Each universe within this multiverse could be unique, with its own set of physical laws and properties. Some might be similar to ours, while others could be wildly different, perhaps even beyond our comprehension. Now, you might be wondering, what does this have to do with the Big Bang? Well, it's quite simple, really. If the multiverse theory holds water, then Big Bangs could be a common occurrence. Each universe could have its own Big Bang, its own moment of creation, happening all the time in these other universes. The theory even suggests that our universe might not be the first or the last to experience a Big Bang. It might just be one of many, each with its own timeline, its own history, and its own future. Our Big Bang, as monumental as it was for us, could be nothing more than a routine event on the multiversal scale. This idea naturally raises a multitude of questions. How are these universes created? Can we ever interact with or observe these other universes? And perhaps most importantly, what are the implications of this theory for our understanding of existence itself? This is just one of many theories that seek to explain what happened before the beginning. If this theory is correct, our Big Bang could be a small event in a larger multiverse. A third theory to consider is the loop quantum gravity theory. This posits a fascinating alternative to the traditional understanding of the universe's inception. Rather than a singular event sparking the creation of our universe, loop quantum gravity suggests a more cyclical approach to cosmic genesis. This theory is grounded in the principles of quantum mechanics and gravity. It postulates that our universe is not the first of its kind. Instead, there was another universe that existed before ours, a predecessor, if you will. According to this idea, a Big Bang-like event could have marked the transition between this previous universe and the one we currently inhabit. Imagine it as an endless cosmic dance where universes are born, live, and eventually die, only to give rise to new universes in a continuous cycle. This Big Bang event, then, is not a one-off explosion, but rather a transformative episode in an ongoing series. The loop quantum gravity theory also suggests that this process could be happening on a scale beyond our comprehension, with countless universes coexisting, each at different stages of their life cycles. This theory challenges our understanding of time, space, and the very nature of existence itself. A universe that is not only expanding but also regenerating, constantly reshaping itself in a never-ending cycle of creation and destruction. This theory implies that the birth and death of universes could be a cyclic process. These are just a few theories that seek to answer the question of what happened before the Big Bang. These hypotheses remain unproven, calling for further research. But what if we got it wrong? What if this entire theory isn't what actually happened? What if our entire universe wasn't created in a Big Bang at all? Join us as we delve into intriguing concepts surrounding the alternative origins of our cosmos. For the 6 Big Bang alternative theories, click on the video below.